Assalamu alaikum. I am Ayesha Waseem and my roll number is 21 TE113. Today I'll talk about Lab 3 of Digital Signal Processing, in which we will represent unit impulse, unit step, and exponentials making signals out deltas. The main objective of this lab is to represent unit impulse and unit step function to make an arbitrary signal out of deltas. We also call the unit impulse function as delta function. If any signal multiplied with delta function, then the result is the same signal. Now we will check all these tasks on MATLAB. In the first task, this is the function of impulse sequence. N0 shows the index and N1 and N2 are the limits. Now we will see this function's example. This is the example of impulse sequence in which limits are from -5 to +5 and the output is shown at the 0 index. So there are the two windows of subplots. In the first window, it will show the plot. In the second window, it will show the stem function. Now we will see the output of these sequences. So these are the outputs of two plots, subplots. This is the plot in the first window. This is the plot which shows the continuous form, and the limits are from -5 to +5. And second window is the stem function, which shows the impulse function. Um, Now moving toward the next task. In the next task, it is the function of the step sequence in which n0 is the index and n1 and n2 are the limits. Now we will check the example. So this is the example of the step sequence in which limits are from -5 to +5 and output is shown at the 0 index. So there are the two windows of the subplots. In the first window, it will show plot, which is the continuous form. In the second window, it shows the stem, which shows spike in impulse form. In this function, we will see the output after delay. In the plot, now we will run this. So this is the output of the step sequence. In plot fig, it shows that from -0.5 to 0, -0.5 to 0, the amplitude is 0, and from 0 onward, it shows the amplitude 1 till 15. So x-axis are from -5 to 15 and y-axis are from -0.5 to 1.5. This is the plot figure in which -5 to 0, the amplitude is 0, and from 0 onward, the amplitude is 1, and 15 continues. 1 is continue at 15. Same as the stem figure, -5 to 0, the amplitude is 0, and from 0 onward, the amplitude is 1. Now moving towards the next task. In this task, we use the shifted variant of the step sequence. -5 to +5 are the limits, which shows the range of the indices. Delta, this is the function of delta, which initialize the delta sequence. Here we set delta 0 at 1. This initialize the unit step sequence. This is the shifted variant of the delta, by which we apply the for loop. We use the command of pause For realization, hold on and hold off are the commands. Now we check the shifted variant by run this task. So these are the output which shows the shifted variant of the step sequence. By applying hold on command, the output is shown like this, in which -5 to +5 are the limits. Now moving towards the next task. So this is the task of even odd function. This is the function of even odd. In even odd case, we want to flip our function. So let's see their example. For even function, the formula is original function plus original function flipped variant divided by 2. And in odd case, input signal minus input signal flipped variant divided by 2. This M shows the flipped variant. And XE is for even, X4 is for odd. We have a signal from 1, 2, 3, 4, 5. This is the subplots for original signal. This subplot is for even part of signal, and this subplot is for the odd part of the signal. 3 shows the rows and 1 shows the column. 1, 2, and 3 are the indexes. Let's run this example. So this is the output of the original signal. This is the even part of the signal, and this is the odd part of the signal. This is the original signal. Next is even signal. For even, the signal is symmetric because the amplitude on the left side is also same on the right side. For example, -1 is the -1, the amplitude is 1, and and on right side on +1 the amplitude is also +1. So this is known as the symmetric signal or even signal. Now next is for the odd signal. For the odd signal shows the reflected variant. For example, -1, the amplitude is 1. Sorry, -1. And on the right side, on 1, the amplitude is +1. Now moving towards the next task. This is the last task, which is the impulse train. T shows the time, which is from 0 to 2 seconds. 0.05 seconds are the delay in time. Here frequency is 1, and CT shows the continuous time signal, which is cos 2 pi ft. In the next, we use the plot in the continuous time signal. In next, sampling frequency, which is fs, which is equals to 50 hertz, and the sampling period means ts, which is equals to 1 divided by sampling frequency. These are the discretization using impulse train. We use the for loop and if else command. Now we will run this signal. So this is the impulse train of the continuous time signal, and it is the discretized variant of the impulse train. So this is the last task, and we complete our 6th task. Thank you. Allah Hafiz.